In this video, we're going to look at two types of sequences, one called explicit and one called recursive. So first, let's talk about what a sequence is in general terms. A sequence is just an ordered progression of numbers. Now, there might be different patterns for how you go from one number in the sequence to the next. For example, it might be an adding pattern, adding 3 every time. Or you could have something where you're multiplying by a number over and over again, in this case, -2. Or it might be a pattern dealing with exponents. So 1 squared, 2 squared, 3 squared, 4 squared. So we have two different types of sequences that we usually focus on. The first way of dealing with a sequence is making an explicit sequence, which means you're going to be able to find the 13th term in the pattern by plugging in the number 13 into the formula they give you. And then when you simplify or compute whatever operations they've given you, it'll tell you what that 13th number is going to be. So the different type of sequence we're going to look at is the recursive sequence. And for recursive sequences, they're going to give you a term in the sequence. Usually it's the first one. They'll tell you what the first number in the pattern is. And then they're going to tell you what the pattern is to go from one term to the next. So they'll tell you, are you adding a number for each term or are you multiplying? And so again, you'll have to use the first term to find the second term to find the third term to find the fourth, etc. So it's basically setting up something like, I know that I'm adding 3, so I can go on and find the next terms in the sequence. So let's focus on the explicit sequences first so I can show you what the formulas look like and how you can evaluate those types of questions. For the explicit sequence, this is the one where you can just plug in the number of the term you're looking for. So if they ask you to find the 5th term, then you're just going to plug in the number 5 into the formula they've given you, and once you compute it, you'll know what that answer is. Now, the nice thing about explicit sequences is they do let you skip around. So if I ask you to find the 10th term, you don't have to find the 1st through 9th terms. You can just plug in n is 10 and you'll get that answer directly. So we'll see that contrasted with the recursive sequences afterwards. Here's the type of formula you will have for an explicit sequence. Now the a sub n here, the idea is that n is going to represent which term in the pattern we're looking for. So if n is 1, then we're looking for the first term in the pattern. If n is 2, we're looking for the second term, etc. So this question is asking me to find the first 6 terms, and then they want me to jump ahead and find the 100th term in the pattern. So to find the first few terms, let's start with that. So if I replace n with 1, that means I'm looking for the first term in the sequence. So I'm also going to plug in 1 over here. And in this case, well, 1 squared is just equal to 1. When you subtract 1, you get 0. So I now know that this sequence starts with a term of 0. So then if I want to find the second term, now I have to plug in the number 2. So my formula is the number I'm plugging in squared minus 1. Well, this time I'm getting 4 minus 1, which is 3. So I just keep continuing this process. I want to find the first 6 terms, so I'm going to do this for A1, A2, A3, A4, A5, and A6, and then we'll jump ahead to A100 in a moment. So if I'm plugging in 3, the third term in the sequence will be 3 squared minus 1. Well, 3 squared is 9. Subtract 1 more, that gives you 8. Plugging in 4, so now I've got 4 squared minus 1. Well, this is 16. Minus 1 is 15. So it might have been hard to figure out what the pattern was doing by looking at the terms in the sequence, but having the formula makes it easy to see what's happening. For the 5th term, I'm plugging in n is 5. This is 25. Minus 1 more is 24. And the last one of these, so I'm plugging in 6 for the 6th term, squaring it, subtracting 1. That'll give me 35. Now, as I mentioned, the nice thing about an explicit sequence is you don't have to find all the terms leading up to the 100th term, for example. So I don't have to keep doing this to find the 7th, the 8th, the 9th. That would take a very long time if so. So now I can just jump ahead and I can say, well, the 100th term is going to come from 100 squared minus 1. And 100 times 100 is going to equal 10,000. So when you subtract 1, you get 9,999. So that's an example of finding the first 6 terms here, first term, second term, third term, fourth term, fifth term, and then jumping ahead to the 100th term. Now let's look at the recursive sequences for comparison. For a recursive sequence, they're going to give you a term, usually it's the first term in the pattern, and then they're going to give you a formula for what you can do with that number to find the next number in the pattern. So you're going to keep repeating the process, then you're going to use the second term to find the third term to find the fourth term, etc. The downside to these is they don't let you skip around, so it's a safe bet that usually when you're dealing with a recursive sequence, they're not going to do something like the last example where they ask you to jump ahead a whole bunch and find the 100th term. They might have you jump ahead a little bit, but usually not as many as like 50 or 100 terms. Now, one of the things that comes up in recursive sequences, you'll often see an a sub n minus 1 or maybe an a sub n plus 1. These are ways of referring to either the previous term in the sequence or the next term in the sequence. So remember, I was showing you that like a sub 3 means the third term in the pattern. Well, if n is 3, what's happening here is if I'm plugging in n is 3, then I'm subtracting 1 from it. So this is referring back to the second term. And if I was plugging in n is 3, usually n is 3 for the third term. Here, if I'm adding 1 to it, then it's telling me that this would represent the fourth term in the sequence. So when you see one of these notations, just know that this is saying use the previous term or this is the next term in the pattern. Let's see an actual example though. So this example is asking us to find the first 4 terms of the pattern and then also the 7th term of the sequence. So here's my first term. I know it's the first term because they're saying b sub 1, so that little subscript right there is telling me which number in the pattern we're dealing with. Now here's the second piece that they'll have to give you. This is my rule. So if I want to find, say the 5th term, so if n is 5, then I'd be doing negative 2 times b sub, and when I plug in 5 here, I end up with b sub 4. So it's telling me to take the 4th term of the pattern and multiply it by negative 2 if I want to find the 5th term. Now this part here is just specifying that you should only use this rule for the second term and beyond. So technically I need to make sure I use this for the first term of the sequence. They're just trying to be careful and make sure you don't try to use the formula for finding n equals 1. Don't use this to find n equals 1. Use this to find n equals 1. They gave us n equals 1. So this is for all the other terms after that. So if they want the first 4 terms in the sequence, well, one of them is already given to us. So you don't need to do anything for that one. So depending on the assignment, if it's having you type in the answers, if they're asking you for the first term, then just use the one that they've provided. Now to find the second term, so now I'm going to be looking for n equals 2. Now that I'm using a number greater than or equal to 2, I'm going to use the formula here. And it's going to be negative 2 times, and remember, if I plug in b sub 2 and subtract 1 from it, it's going to end up being negative 2 times b sub 1. And b sub 1 was my previous number in the pattern, so that means this is negative 2 times 3. So my next term is going to be negative 6. And then if I want to find the third term, it's still going to be negative 2. It's always going to be negative 2 times. And when I'm plugging in as n is 3, this time it's going to be negative 2 times the second term of the pattern, because I'm plugging in 3 minus 1, so now it's the second term. Well, the second term we just found a second ago, it was negative 6. So now my next number in the pattern is 12. So one of the nice things with recursive sequences, once you understand what you're doing operation-wise, you can actually kind of just start to go a little bit faster through this, and you can probably start to recognize, okay, without showing all this work, I know that I'm going to keep multiplying my numbers by negative 2. So for my next number in the pattern, it's going to be negative 2 times my previous number, so it's going to be negative 24. My next number in the pattern is going to be negative 2 times the previous number, so it's going to be positive 48. And then this one wants us to go all the way up to the 7th, so then let me make some more space over here. So the 6th term would be negative 2 times this number, so we've got negative 96, and then we need to do it one more time, because unfortunately I wasn't able to skip ahead. After finding the first 4 terms, I wasn't able to just skip to the 7th. I still had to find the ones in between leading up to it. So b sub 7 is going to be negative 2 times this number, so we've got positive 192. So that is the pattern for dealing with both an explicit and a recursive sequence. So remember, explicit ones you can skip ahead. You just plug in the n value for the term you're looking for. And for recursive sequences, you have to kind of go through in order and find all the terms leading up to the last one that they've asked you for. So that's it for the lesson on explicit and recursive sequences.